big rectangle in the middle. And you've got 4 smaller rectangles on each side. And then the arrows are important. So look at the direction that the arrow is going. So the rectangle on the top left has an arrow going in,
And out.
but the one on the bottom below it has an arrow coming out.
So is the one on the bottom.
Yeah, and then the rectangles on the right, both of those have got an arrow going in and out. So once you've done that, you're going to label that diagram.
Yes, I'm finished.
Okay, so what's that big one in the middle then?
CPU.
Good, right, CPU, good. And then top left, we've got an arrow going into the CPU. So what word do we need there?
Right. Is it? I have a question. Is it all of those components on the top, or is it?
No. No, this is the diagram of how the processor works.
Oh,
So if the big middle one is the CPU, the processor, what's going into the processor? Or what word that we used last week? So it means data going in. So what's the word for data going in? Just turn the word around. In.
Input.
Good. Good. So top left is input because it's data going in.
And
then it's going into the processor. And then the bottom one.
Output.
Good. Output. And then on the right-hand side, so we've got the data going into the computer, we've got it processing the instruction that we want, and we've got the data coming out. But before we do that, what else have we got going in and out? 2 things. So one is this one.
Brain.
How do we remember things? How does the computer remember? Memory, good.
Memory.
And how about if we want to keep our data?
Storage.
Good.
Yes.
Okay, now below that, put a heading, fetch, decode, execute, and you need to draw this little diagram.
Yes.
So it's literally going in a circle because it just keeps doing one instruction after the other. So make sure that arrows go in between the boxes.
Yes.
Okay, so what words are you going to put in those boxes? So on the top one, what are you going to write in there?
Fetch.
Good. Fetch the instruction.
Yes, fetch instruction.
Good.
Decode.
And then follow the arrow. What's the next one going to be?
Decode.
Good. Decode the instruction.
And then execute the instruction.
Good. Execute the instruction.
Yes.
Right, so let's check now and see how many marks you've got. So each of these are 1 mark each. So number 1, what does RAM stand for? RAM is random access memory. Have you got that?
Let me see. Yes.
Good. So nice big tick and put a 1 in the circle. And then number 2, what is the purpose of RAM? What have you got? Number 2, what is the purpose of RAM?
RAM is number 2. It is volatile. I said RAM
What did
saves.
you write? What did you write?
RAM saves temporarily data.
Good. So big tick and put a 1 and put a circle around the 1.
Yeah.
Number 3, what have you written? What is the meaning of volatile?
Volatile is when data is lost when a computer crashes or shuts
Good.
off.
Yep. Big tick and a 1 in a circle. And then number 4, name a type of computer memory that is volatile.
RAM is a computer memory that is volatile.
Yep, number 4, what's your answer? Name a type of computer memory that is volatile.
RAM.
Good. So big tick and another 1 in a circle. And then number 5, what does ROM stand for?
Read-only memory.
Good. So big tick and a 1 in a circle. Number 6, what is the purpose of ROM? What have you written?
ROM saves instructions.
Yes, to do what?
That makes the computer like button.
Yeah, to start up the computer. Okay, yep, tick and 1. What is the meaning of non-volatile?
Non-volatile doesn't lose data when computer is turned off.
Good. Big tick and 1 in a circle. Number 8, name a type of computer memory that is non-volatile.
ROM.
Good, yeah. Read-only memory. Big tick and 1 in a circle. And then what 3 processes does the CPU perform in a cycle?
Fetch, decode, execute.
Good. Big tick and 1 mark. And then if the processor speed is 1 kilohertz, how many instructions are carried out per second?
1,000 per second.
Excellent. So how many marks have you got? Count up how many marks you've got.
3, 4, 5, 6, 7, 8, 10.
Excellent. So write down 10 out of 10. And now let's mark this one. So the first one, number 1 on this activity was motherboard. So did you get that?
I've done the left the same, but I've done those 2 the other way around. The storage instead of the storage.
Oh, it doesn't matter. Don't worry. Those 2 on the diagram, because they've both got arrows going in and out, it doesn't really matter. Let's do the other ones first, though. The motherboard, etc., on the top. Okay. So have you got number 1 there somewhere? Motherboard.
Yeah, motherboard.
Good. Tick that one.
CPU.
Good.
RAM.
And then number 3 is
RAM.
good.
Graphics card.
Number 4. Good. Big tick, tick, tick.
Hard
Number
disk
5.
and data bus.
Good. So you've got 6 big ticks, have you?
Yes.
Good. And now label the diagram. So go and tick those off. So check. Have you got CPU, the big one in the middle?
Yes.
Good. And you've got input with the arrow going in?
Yeah.
Good. Tick that one.
Yeah.
And then you've got... Do you know, I've done a silly thing.
It should have been out.
I've done a silly thing. I've put my arrow the wrong way around. Okay. Make sure your arrow is the other way around. And then storage and memory, that's fine because we've got the arrows. That's good. And now the last one there. So the fetch the instruction.
Yeah, fetch, decode,
Good.
and
Decode
execute.
the instruction and execute the instruction. Good. Well done. Now then, let's see if you can manage this one. So, can you explain how input, process and output is used within the clothing manufacturing company to produce smart clothing?
Yeah, and
So
so
you think of what somebody might want in a piece of smart clothing to input data.
yeah, so first they use this machine to say what they want the clove or the not the clove
Now, actually, the pictures are a bit confusing because that e-printer is the output, isn't it?
Yeah. Oh,
Yeah. So what might be input? What might you want in a piece of smart clothing? Let me give you an idea as well. You know, some people wear watches, Fitbits, and stuff like that. So data is input into those. You know, people worry about the amount of steps that they take. So that's all input. It's going inside the processor of the watch. And then the processor is taking that instruction, and then the output is it's displayed on the display screen, so you can see how many steps that you've done. So we even call things like Fitbit, smart clothing. So can you think of other pieces of smart clothing that you might create, or a manufacturer might create in a company?
So say it's like that, something like that jacket. Yeah,
Okay.
But it can warm up.
Okay.
And or say when you're wearing your shoe, it can if you step in like a puddle, it can dry up.
You could actually put like heating elements into a piece of smart clothing. So if you actually made a jacket, you could use input inside the actual jacket, so that the process would be to actually heat them up. Do you ever go skiing?
No.
Oh, okay. Have you ever seen gloves that
Yes, yeah.
will warm up?
Yes.
What they have is a piece of technology that, for instance, when it's snapped in half, it's activated, and then the process is that it heats itself up. And then the output would be that it's warming up the jacket. Do you know, they even have, I'm sure you've never seen this, but you know, like a can of Coke?
Yes.
You can actually get cans of coffee. Now, you're supposed to drink coffee hot.
Yeah.
So they have these cans that when you use the ring pull, that's the input. It activates the instruction to say, processor, I want you to heat up this coffee, and literally that can will heat up the contents. Have you ever seen those?
No.
Bizarre, isn't it?
Yes.
Okay, great stuff. Any questions, or are we okay?
No questions.
Good, we've done a lot, and you've done well.
Thank
I'll see you next week.
you. Bye.
Bye.